LISP IPv4 multicast routing. In this video, I am going to talk about the LISP IPv4 multicast routing, and I'm sure that you learned about the multicast in previous courses because this is a prerequisite for this video. If you don't know about the multicast, you can bypass this video and jump from this video to the next video because the prerequisite of this video is the multicast knowledge. But I'm going to talk about the multicast routing in LISP in this time, but the multicast in IP environment is the requirement of this video. Let me to talk about the multicast. Why we need the multicast? In an enterprise or data center network environment, it is very common to have applications with multi-destination traffic. Do you know what is the multi-destination traffic? Yes, you know. The multi-destination traffic is destined to multiple end users or multiple receivers which might be geographically dispersed. Most of these multi-destination applications use multicast, and thus it is vital that the infrastructure be capable of carrying multicast. LISP infrastructure also provides support for multicast traffic, but there is a difference between how LISP handles unicast packets and how it handles multicast packet. In this video, we will learn about the multicast routing in the LISP for IPv4. Let me to talk about a little about the component of the LISP first. After that, we can start talking about the IPv4 multicast routing in LISP. First, let me to review these terms. Source Endpoint Identifier or SEID. What is the SEID? You know it. The SEID is the source host. You know it. Receiver Endpoint Identifier or REID. What is the REID? REID is the receiver host. Okay. For example, assume this server is sending multicast traffic. This is the IP address of this server is the source EID, okay? And the PC3 and also PC4 are receivers. Because of that, we have two receiver EID. So simple. Also, let me talk about the source routing locator or SRLOOK. What is the SRLOOK? SRLOOK is the ingress tunnel router ITR on a multicast tree. For example, in this example, as you can see, the source RLOOK is the router 1, okay? It's the RLOOK of router 1. And then receiver routing locator or RRLOOK. The RRLOOK means the RLOOK of the receiver host. For example, this is the R3 and R4. For example, if the PC3 and PC4 are receivers of the traffic of this server, we can say that the R3 and R4's RLOOK are the receiver RLOOK. Because of that, now we know about the SEID, REID, SRLOOK, and then RRLOOK. Okay, unicast and multicast routing work on different LISP semantics. You know that for unicast packet, LISP semantics require mapping of both source and destination address, whereas for multicast, LISP semantics only require the mapping of the source address. Let me talk about this. You know that when we are using LISP for forwarding the unicast packets, we need to advertise both source and destination to the mapping server. For example, in this scenario, assume that we are sending one unicast traffic from PC2 to the, for example, PC4. This is the unicast packet, okay? Let me to write here the source IP of this packet is 192.168.210, okay, 192.168.210, and destination IP address is 192.168.410. This is a unicast packet, okay? In unicast routing or in unicast communication, we need to advertise both of the source and also destination address to the R5 to the mapping server. Here, look at here in this example, we can say that R2 as the ETR should send the 192.168.20/24 as the EID. Okay, this is the EID as you know, to the R5 with its RLOOK of the router 2. Assume that this is quad 2, for example. And now in R5 means in the MS we have this information. Also, beside of this, we need another mapping, the mapping from the router 4. Router 4 should advertise the EID of 192.168.40/24 with the R lookup, for example, quad 4. And after that, we will have communication between the PC2 and PC4. This means that in unicast forwarding for unicast packets, we need to mapping of both source and destination address. But in multicast, we have different conditions. Let me to show you. Look at here. Assume that we are sending now from a server, from this server, one packet with the destination. This is multicast. Let me to write here multicast. We are sending a packet to a group of multicast, for example 226.1.1.1. that's it. Okay, you know that this is a S, packet. S, means the source IP, and after that G means the group IP address. Okay, this is from the multicast, our multicast knowledge. The source IP of this for example packet is 192.168.110. okay, and the destination IP, as you can see, is 226.1.1.1. about the multicast, okay, we don't need to advertise the 226.1.1.1 to the mapping servers. Only we need to map the source IP. Here we have a difference. Look at here. Let me to write here. The only things that we need is advertising from the R1 as the EID. This is as the ETR, the EID of this network 192.168.10/24 with the R lookup quad 1 to the MS. As you can see here, we have a difference. The difference is that in unicast we are advertising both on source and destination address, and whereas for multicast, Lisp semantics only require the mapping of the source address. This means that the source address are more topologically significant than the group address. Okay, and Lisp support multicast environment, and we can talk about the Lisp detail about the how Lisp can forward the multicast packets. In Lisp, we can forward the packets from the source to multiple destination with two methods. Let me to talk about these two methods. The first method, okay, here we have two replication method. Let me to write here replication method. The first replication method is unicast, okay, unicast head end. We call it unicast head end replication. That's it. And the second replication method is the native multicast replication. Native multicast, okay, native multicast replication. I'm not going to talk about all of the detail of these two methods, because in this video we will talk about only the unicast head-end replication, but we will learn about the native multicast replication in future videos more than this video. But let me to give you a brief overview about these two type of replication. You know that when we are sending traffic from this server, the traffic finally should receive to all of the receivers. Assume that the PC3 and PC4 are receivers of this traffic. The first method of forwarding the traffic to the for example PC3 and PC4 is encapsulating at the head-end router, the R1, two packet with destination R look of R3 and also R4. This means that in the router 1 we need to encapsulate the packet with two destination. The first packet should be encapsulated with the source IP of the R look of router 1 and destination IP of the R look of router 3, and also we need to replicate it with the destination IP of the R look of router 4. Unicast head-end replication, this is the unicast head-end replication, is also known as the unicast tunneling method. In this method, the replication of multicast traffic happened at the root of the site. This is the root site, which makes it possible to carry multicast traffic over a network that does not support native multicast. This means that here we don't need to supporting the multicast, because you are tunneling traffic from R1 to R3 and also to R4. Okay, here we are sending only unicast packets, because of that this core, this R look address space doesn't need to support the for example, multicast, unicast replication for an SEID G, because look at here, this is the